Okay, we're going to start Unit 3 today, which is about describing relationship for bivariate data, or data on two variables. Today we're going to talk about scatterplots and correlation specifically, and next time we're going to talk about least square regression. So, just really quickly, typically when you examine data in statistics, you collect more than one variable for each subject, right? So sometimes some of those variables qualify as explanatory variables and some are response variables. The difference is the response variable measures an outcome, and explanatory variable is something that may help explain it. For now, we have not discussed what is required in order to assume a cause and effect relationship. So we are never going to assume causation until we learn what specific requirements there are to show causation. Now, a scatterplot is the most useful way to show a relationship between two quantitative variables. They have to be quantitative, right? And they have to be on the same individual or the same subject. The values of one variable are on the horizontal axis. These are your explanatory variables, are always on the horizontal axis. And your response variable will always be on the y-axis. I believe in science they refer to independent and dependent variables. So each observation appears as a point on the graph. To make a scatter plot, you have to first decide what's your explanatory variable. Explanatory is going to go on the x-axis. So the letter x in both explanatory, x-axis, right? Kind of helps you remember. Make sure you're labeling your axes. Make sure you're plotting values as points. And then, of course, you don't forget a title. So here's a nice example. It says, make a scatter plot of the relationship between body weight and pack weight. Body weight is your explanatory variable in this case, right? We're going to put it on the x-axis. So there it is. It's labeled. And then you're going to do backpack weight as your response, okay? And then each of these observations is a point. So this is a point 120, 26. It represents 120 pounds of body weight. And this particular individual has a 26-pound backpack. And this is what we call a scatter plot. So to interpret a scatter plot, you have to look at the overall pattern, right? You're going to look for departures from the pattern. And the three things you want to make sure you hit on are direction, form, and strength, right? So outliers play a significant part here. So we need to watch out for those. And any strong deviation from a pattern would qualify as an outlier, right? So here you can tell the direction. It's moving in a positive direction, right? The higher the body weight, the higher the backpack weight in general, right? So there is a moderately strong, so that defines strength. Positive defines direction. Linear implies that a straight line kind of describes it, right? Relationship between body weight and pack weight. It appears that lighter students are carrying lighter backpacks. Again, no causation, right? Just appears that there's some form of association. So again, strength, direction, form, right? If there is an outlier, you do want to mention it. There's one possible outlier here when you look at your line, right? This one's kind of far from it. And there's a student apparently with 187, that weighs 187 pounds and carries a fairly light backpack, comparatively speaking, to the rest of the data, right? So when you're interpreting, you're going to look for the positive or negative association, right? So, so when you look at this SAT example right here, right? This is percent taking SAT, and this is the mean math score, right? Page 144 of your book has this example, right? You can tell that the form is not quite linear, right? So it is moderately strong because you can see the form in this relationship, right? It's negative, it's curved, right? It's not linear, it's curved, right? Relationship between, and you have to name, this is your context, right? Between the between students in the state who take SAT and the mean SAT math score. Further, there are two distinct clusters of states and two possible outliers that fall outside the pattern. So this is what your description will look like. You have to talk about strength, direction, form, and if there are any outliers, you want to make sure you mention those. What measures the strength of a linear association is something we call correlation. We use letter R. It has a fairly complicated formula, but we're not going to worry about the formula. We're just going to know what it is. I'll show you the formula in a minute. But we more have to understand what it is. So correlation, which we denote with letter R, measures the strength of linear relationship between two variables. Its values are always between -1 and 1. So it can't be greater than 1 or smaller than -1. If R is greater than 0, then you have a positive association. If R is less than 0, it's a negative association. If your R value is near 0, it indicates a very weak linear relationship, okay? The strength of the relationship increases as you move closer to +1 or -1, with +1 being perfect linear relationship, so all the points fall exactly on the line, and -1, the same thing, very strong, just in a negative direction, right? And that's your perfect linear relationship. So here are some examples, right? Correlation of 0, correlation of -0.3, so it's not very strong, but you can tell it's negative in direction. This is positive in direction, 0.5. Again, they're not very close together to the line, right? -0.7, you can see they're kind of closer together. This is positive 0.9, and this is -0.99. So you can kind of see how the strength is different based on the value of R. The formula is complex, and we're not going to go through the formula, but you can certainly look at it. It's just a summation of these products, right? And then, of course, divided by n-1. How correlation behaves is very important. So correlation makes absolutely no distinction between explanatory and response variables. So if you were to switch explanatory and response variables, your correlation coefficient is going to be exactly the same. R will not change if you change units. If you had something in inches and you change it to feet and graph it again, your correlation coefficient will be exactly the same. And the correlation has no unit of measure, so we never assume any kind of unit with correlation. Both variables have to be quantitative. It does not at all describe a curved relationship. This is only for a linear relationship, right? You can have a perfect, strong relationship that is curved, following beautifully, be it a parabola pattern or a logarithmic pattern, but R value will only talk about or mean a linear association, okay? Correlation is not resistant. Any outlier will affect it greatly, okay? And correlation, of course, is not a complete summary of the data. You always have to graph it. You always have to make a scatter plot. So I think we're going to go quickly through these. So there are several sentences, phrases, I guess I would say, that we need to make sure we memorize. And we always have to put context. So things that are underlined are things you will have to add for context. So when you are interpreting R, you have to state if it's positive or negative, so pick a word. Weak or strong, sometimes we say moderately weak, moderately strong, so you can put an adjective in front of weak or strong. Linear, because it's R value, and it's only going to matter for linear association, okay? Between, and then you'll put context here with the explanatory variable and the response variable. R squared, we haven't talked about it yet, but it's just the value of R squared. And it's always a positive value, because anytime you square a number, you end up with a positive value. That means that X% of the variation, so whatever R squared is, could be 0.8, right? Then you would do 80% of the variation in the, whatever the response variable is, you have to put the context in there, can be explained by the approximate linear relationship with the explanatory variable. Again, put the context in there. We have to be able to talk about slope and y-intercept in context as well, but we will cover that in more detail in the next lesson when we actually talk about linear regression. That is it for today, guys. I hope to see you in class next time. Have a great afternoon or evening, and we'll see you later.